Hi everyone, and welcome back to my channel. In this video we will be looking at the difference data joins make for our SQL results, and then we'll be troubleshooting data joins to get the result that we want. In this video we'll be using Google Cloud BigQuery. So to get to BigQuery, you log in on your Google Cloud account. The navigation, you navigate to BigQuery, and then you just double click on BigQuery, and then you'll find this interface on my screen. You'd want to add your data, and that's what we are doing right now. To add data, you click on add data. You'd find that on the BigQuery interface. You add data, you scroll down a little bit, just as you will see on my screen. So BigQuery has some Google Analytics data from Google products. So that's the data we'll be taking advantage of. So you want to start a data. So you just click on start a project. You enter the name of the data that you want. The data that we are going to be looking at would be data to insight. So you enter that and then you start it. I already did that. So once you start it, it appears here by the right side of your panel. So you have data to insights, and then you can expand to see the repositories, all of the tables, the models, and all that. So we are looking at all sessions raw. Once you click on it, it shows you a schema. So it shows you the schema for that table. So when you click on that schema, it helps you determine what relationships the different tables have. Okay, so let's start with our first query. We want to find out how many products are on the website, and this is the first time we're using BigQuery. You'd notice that after our from, would have to mention data to insights, that's the project, dot the table, dot the particular data set it's coming from, and then the table. So in this query we're trying to determine how many projects we have on the website. So in our first query, so you want to pause a little bit on our first query. Let's just explain it in more depth. On that first query, the first query that we entered, we selected distinct product SKU and then product name, and we found that we had our result had 2,273 rows. And then when we selected only distinct product SKU, we had only 1,909 distinct SKUs. So what does that mean for the relationship between SKUs and product name? So that would mean that it's not a one-to-one relationship, right? It's not a one-to-one relationship. So in examining the relationship between SKUs and product name, since our result for only SKUs gave us fewer number of rows, that will mean that there are some products that some products share one SKU, which is not supposed to be so, because your SKU is supposed to be an identifier for a product. So in this third query we are going to run, we are still going to use this query to examine that relationship between SKU and name. So on our screen, we want to count distinct SKU as SKU count, and we want to also write the distinct product as SKU, and we want to run a string aggregate function on that. So that means that, looking at our second query, when we run this for every product SKU in one row, right, we are going to have the list of products tied to that SKU. So you see from our where clause, our product SKU is where our product SKU is not null. We want to group by product name, having SKU count greater than 1. So let's quickly run that and see what we are going to have. Yeah. So since we grouped by product name, for every product name, we count how many SKUs that product has. So for example, Ways Women's Typography, that product has 12 SKUs, and those SKUs, it's the other way around. Those SKUs are grouped with the string aggregate function. So just in one row, we have all of those SKUs separated by a comma. That's what the string aggregate function does. Since we are grouping by product name, so it's going to kind of, for every product name, count the SKUs attached to that. That's the second column. And then in the third column, it writes out all of the SKUs in a string, right? Puts them together, tied to one column. So this means that some products have more than one SKU. That's simply what it means. So if some products have more than one SKUs, it means that if we use then one SKU, if we used one SKU, then one SKU could point to one product, but one product could be pointing to many SKUs. So let's, like swap this. We want to check if, in fact, it has the same relationship when you reverse it. So now we are going to group by SKU, which we've done, and then product name. Now, what do we notice? We notice that for every product SKU, we have many product names. So for sure, it's not a one-to-one relationship. But there's something else I see here, right? Every SKU that's been tied to many product name, I feel like those product names are just the same product, listed so many times on their website using different names. So for whatever reason, somebody listed, for example, let's say the Android 24. Yeah, it's just a name, water bottle, different kinds of water bottle, the same water bottle but listed with different names and given one SKU. That is what I noticed from that. So what do we do? So does that now mean that the product SKU is a unique ID? Not really. What we see here is a many-to-many relationship, and this would be an issue in our SQL for retrieving data. So let us look at another pitfall. The pitfall here is that we don't have a unique ID. There is no unique key. So in every inventory tracking, an SKU is designed to uniquely identify one and only one product, and for us, it will be the basis of join condition when we look up information from other tables. So when we have a non-unique key, this can cause serious data issues, as we are going to see right now. So let us check out this query. We want to select product name and product SKU, where the product SKU is this SKU on the screen. So we are going to see that it's going to give us more than one product. So this means that even though our SKU is supposed to be a unique key, as it should be in real life, for our table, it's not. So yeah, like I was saying, the problem with this is that we don't have a table. This table, the e-commerce.all-sessions raw table, does not have a unique key. It does not have a unique ID. So we're going to run that soon. So now we are going to look at the impact of joining on a data set with multiple products for a simple SKU, as we have seen. So let us explore the product inventory data set or the products table to see if the SKU is unique there. So we are going to select SKU, select name, and select stock level from our data to insights project in the e-commerce table, in the e-commerce data set from the products table. That's the way we are going to read the table where this is going to come from. So where the SKU is the SKU we just checked in the last query. So I'm just going to paste it. So we say that in the product table there's just one entry for that particular SKU, which is a 7-inch dog Frisbee, and the stock level is 154. So that means that in the other table, the all sessions row table, right, it's an unintentional many to one SKU relationship, and we are just going to show that now, because when we join the inventory data set against our website product names, so we have like a product table and the all sessions row, it's like, so when we join that, you'll see that we are going to have the results we would have would be false, and that's because the many to many relationship we have causes a false SQL result. So I'm just going through the schema just for you to see what the schema, the SKU name, the stock level, and all of that, how it look like when you look at the schema section of this data set. So in our next query, we want to select distinct website product name. So if you're ever confused about what any of the columns that we select in this video means, please just get back to the schema section and take a quick look. Just look up on that table, look up the schema. You'd find the definition for every column name. So next we want to select distinct website.product name, website.product SKU, and inventory.stock level. So because these three columns will come from different tables, we are going to use a join. So we want to join our all sessions row. We are going to call it website. So we want to join that to the products table, and our products table would call inventory. So that means we are going to use an alias as. So I'm just going to paste the query. So of course we join on, and then we use a where clause to specify the particular product SKU. So when we join the product name, SKU, and stock level, we find that because the website table has a repeated mention of that product, tying it to one this SKU, we find that we are going to have multiple entries in our result, which is false. So we'll run that in a minute and we'll see how that plays out in our result. So we see that that product appears 3 times. So there is a repetition, and if you didn't inspect your product table first, you would think that there are 3 different products, instead of just noticing or knowing that it's just one product but in 3 different names. So let's look at our next query. In this next query, we'll use CTEs. So width, as we often define our CTEs, width. So with inventory per SKU. So with our CTE, we want to select product SKU and the stock level from inventory per SKU, which is our CTE. So what our CTE does is everything our first query, the query before this one, did. So does everything the query before this one did, but then we want to pull this data from CTE. So let's quickly run that, and then let's see the result that we have. So you see, it shows 154 times 3, which is 462. So it's showing 3 times, triple the inventory. So this is an unintentional cross join, and we are going to take a closer look at unintentional cross join pretty soon. So let's move on to the next query. And in this query, our pitfall solution is to use distinct SKUs before joining. So we've noticed why this is giving us a false result. So as a solution, we want to use distinct SKUs before joining. So as you can see, we can gather all the possible names into an array. Since we have seen that we have far more names than we have SKUs, so we can pick for every SKU what are the names tied to this SKU. So this is what this SQL query is doing. It selects product SKU, then it ties all of the distinct product names that are tied to that SKU into an array aggregate function. And that column has been called push all names into array. So that means that for every product SKU, we get to see all of the names tied to it. So now, instead of having one column for every product name, we have a row for each unique SKU. So if we wanted to deduplicate the product name, we could limit the array. So that will be the next thing we want to try. We can limit the array. So in limiting the array, that means that in our array aggregate function, instead of having all of the product names listed, we can limit it to just one. So we can say limit 1. So instead of listing 7-inch dog frisbees in 3 different ways, we could just have the first name, and then we could run with that first name, adopt it as the name of that product. So fast forward, we can also lose data records after joining. So in this query on my screen, we select website.product.sku from the website table and from the inventory table, which is just the product and all sessions row table, and then we join them. So what happens? So we're going to get one row called product SKU, but you'd be surprised to notice that this has given us, instead of 1,900 plus, we have 1,090. That means that some SKUs are missing. So instead of doing that, we can select the SKUs from the 2 tables and then join. So that's what we have on my screen right now. The SKU from the website, the SKU from the inventory, that's the product table. So when we join them, you see that there are some SKUs that are present in both tables. You see that there are some SKUs that are present in both tables. And we still have 1,090 records. So how do we find the missing SKUs? It means that the kind of join we are using is wrong. We either use an outer join, or a right join or a left join. So the default kind of join we've used now is an inner join, which only matches records from two tables. So we need another kind of join that can give us records that are on the left but not in the right, or at the right not in the left. So we are just going to rewrite that query, which we'll be doing very shortly, and we'll do a left join instead. Remember, we've had this video where we talked about different kinds of join. We have the inner join, left join, right join, full join, cross join. The default join is the inner join, which is what gave us this false result. So we are going to try left join, and when you run the left join, let's see. So when we run the left join, we now have 1,900 plus SKUs, which is our actual number of SKUs. Okay. So that means that in one of our tables, yeah, as you can see on the screen, the inventory SKU has some missing SKUs. So we have some SKUs missing from our product inventory set. So I think let's now check. We want to find out what SKUs are null in our inventory table. So let's paste in the query, the right query that will do that for us. We want to select the website product SKU and the inventory SKU. Perform a left join where inventory SKU is null. That will be our where clause. So when we do that, we find out that we're just going to run that, and when we run that, that's going to answer how many products are missing from the inventory dataset. We find out that a whopping 819 products are missing from the inventory dataset. So why is that? So that will be a question to answer. Maybe your warehouse manager has to answer that. Why is that? Okay. So we can even pick one SKU to confirm. So we can select everything from dataset-inside.ecommerce.product, put in that SKU, and we find, just to confirm that it doesn't exist in the inventory table. If we picked one of those website SKUs that doesn't appear in the inventory SKU, we'll find out that it will return 0 results. So now that we've confirmed that it returns 0 result, that confirms that some products aren't captured in the inventory SKU. So why is that? Who knows? Maybe some SKUs might be digital products and are not stored in the warehouse. Or maybe there are old products that were sold in the past on the website and are no longer offered in the current inventory. Or just maybe there are some products that are never sold or never stocked in the website. In the warehouse, they are never stocked in the warehouse. So, or maybe there's just a missing data from the inventory and that should be tracked. So it could be all sorts of reasons. So now let's think about what the reverse situation would be. Are there also products in the product inventory that are missing from the website inventory? That will be the next thing we would check, and we'll paste in the code for it, where we select the product SKU as website SKU, we select the inventory SKU, and then we do a right join instead of a left join. So let's see. So we have only two. So there are actually two inventory SKUs that are not in the website SKUs. So why could that be? So it could be that those products are only sold from the website. You would have to come in person to the not website, are only sold from the warehouse. You would have to come in person to the warehouse to pick them up. So as we can see, when we run website product SKU and then join it with the inventory information, so we have inventory.star, if you see that. So we select everything from the inventory table. We find that it's either there is a new product with 0 orders. So because nobody has ordered it from the website, the SKU doesn't appear on the website SKUs yet. Or maybe there are products that you can only buy in store or from the warehouse only. So that's because when there are products that haven't been sold from the website yet, they don't show up in the web analytics until they are viewed or purchased. So that could be one of the reasons why. So let's find out, what if we wanted to list all the products missing from either the website or the inventory? So we've used left join, we've used right join, but what if we wanted to find them at the same time? So for this, we would use a full join, because a full join is inclusive of both the left and the right join. And we anticipate that since the left join gave us 819 rows and the right join gave us 2, so 819 plus 2, that will be 821. We would anticipate that we would have 821 product SKUs when we use a full join, which is So the next problem we'll look at is unintentional cross joins. So what's that even? So because our cross join matches every item from the two different tables, from the two different columns selected from the two different tables. For example, if we had 5 items selected from the first table and 4 items selected from the column from the second table, the resultant result will be 20 rows, because each of the 5 match each of the 4. Each of the 5 in the first column from the first table match each of the 4 from the second column from the second table. So there's a trouble with cross joins, because you can unintentionally have the wrong result. So in this example, we want to create a table called site-wide promotion, and we just want to fill up that table with one column called discount, and it's just going to have 5%. So once we create that, the next thing we want to try is to find out how many products are in clearance. So we want to select distinct product SKUs and product category, and then the discount we just created. So if we did a cross join, that would mean that we wanted all items in clearance to have a 5% discount. So you could, when you create a table, you can always look at the schema of the table you just created. So, and you can always select that table to kind of like confirm that the table you just created is correct. So like I was saying, If you, for example, selected all the items in clearance and cross-joined with a value in your discount table, so in our case, that would mean that all items in clearance would have a 5% discount. This might make sense. So one of the things you would notice is that for a cross join, we don't need to join on any column. That's because, like I explained, by default, it just picks one item from each column and then matches it to each of the items from the other column, and it repeats it all over until everything is matched for the number of times, for that number of times. So we don't have like a cross join on. We really don't have that. So, but let us say that hypothetically we had different percentages of discount, let's say 4%, 3%, or what have you. So that means we are going to insert into the discount table we just created. We're going to insert 4%, 3%. That's what we're going to do. And we're going to try this again, just so that we see what happens. So if we check that discount table, we'll see that now in our discount table we have 5%, 4%, 3%, which is great. Yeah, which is great. So now let's try the first query again. That is, for every item that is on clearance, let's try to match it with how much discount. So if we did a cross join, it's going to be a mess, because each item now would have, you see rows 3 and rows 4. If you looked at it, it's one item, but it has a discount of 5%, it has a discount of 4%. So each item now has a discount of all of the 3 percentages. So and you also notice that instead of just 82 items, you now have 246 items, which is like 82 times 3. So that means each item is appearing 3 times with 3 different discounts. So I'm sure you can see why we have this problem. We have this problem because we used cross join. So what was the impact of the cross join? The 3 discount codes, when you use cross join, you just multiply the original dataset by 3. So the solution is to know your data relationships before you join, and you don't always assume that keys are unique. So before every assumption, please check. I think we are going to end this video here, and I hope this was really interesting. It was for me. We will meet on the next video, so keep your fingers crossed, and I'll see you on the very next one. And if you haven't subscribed, please do.